that is the end of the cardiovascular system. But as I promised you while you are looking at the renal system, that I will join one more thing finally. And I don't have a slide for that one, so you can just listen. It's a small process. So assume that we said that the blood pressure is usually maintained within a certain range. So what happened then when you have an hemorrhage, when you bleed all of a suddenly that your blood volumes goes down? What happened at that point in time? A system will be activated, and that system only has one aim, is to ensure that we restore the blood pressure back. And how does it achieve that one? So this is an interplay between the heart or the cardiovascular system together with the kidney, which is the renal system, and a little bit of also the coordination of the brain. So the event begins once we have a severe hemorrhage or hypovolemia. We have the receptors in the kidney. Remember what you call the GFR, the glomerular filtration rate, and we have some sensors in the kidney. Once those sensors detect that the blood pressure has gone down, let's say we know the normal blood pressure is about 120 out of 80. And at this point in time, someone has suffered a severe bleeding and their blood pressure has gone down to, let's say, 70 out of 50. Those sensors will be activated in the kidney immediately, which will cause the release of a certain hormone that I mentioned initially, that we have an hormone secreted by the kidney beside the APO, which synthesizes erythrocyte or red blood cells. We had another hormone that we call it renin. Renin is an hormone secreted in blood pressure, and low blood pressure will lead into secretions of some other factors in the kidney. So being an hormone, or we simply also just treat it as an enzyme, because we know all hormones almost act as enzyme. So this renin will act on some protein secreted by the liver that is usually just flowing in your blood. We call it angiotensinogen. Angiotensinogen will be converted into angiotensin. And angiotensin 1 is not active, it's not potent, it doesn't do any function, it's not physiologically active. So it has to be converted into its active form, which is angiotensin 2. And that one is done by some enzymes that is usually produced by the lungs, but it circulates around the body. We call the enzyme angiotensin converting enzyme, or simply ACE. So once we have angiotensin 2, is a very potent vasoconstrictor one, and it will vasoconstrict the blood vessels and increase the resistance, and in that way the blood pressure will increase a little bit, but that one is not sufficient to increase the blood pressure or to rather rescue. It will also cause the kidney to release another hormone that we talked about in our previous class, that we call it aldosterone. Aldosterone was a mineral corticoid that will cause the retention of water. Aldosterone will increase the retention of water in the kidney and ensure the volume increases. So that one will boost the intravascular volume, and at the same time, the pressure will increase. Aldosterone equally increases or activates the thirst center in the brain, in the hypothalamus, and that one will give you a desire to drink water. And once you drink water, your internal vascular volume will increase and it will restore your blood pressure. So you can just read about that system. We usually call it Renin-Angiotensin-Aldosterone System, or simply RAAS. So that's RAAS. So thank you. And that will bring us into the end of this section. Unless you have any question, we'll end the session there. So at least now you know that when you go and take your blood pressure, your BP machine, you know what you are recording.